Hey everybody, this is Larry, this is me going with Q3 of the weekly contest 448, merge operations for minimum travel time. Hit the like button, the subscribe button, join me in Discord, let me know what you think about this one. This one clearly I had a lot of trouble with. Honestly, it wasn't quite that I misread it, but I definitely misunderstood it in that I was trying to compress the states too much, if you will. And honestly, the reason was premature optimization. I tried to compress too much states, but once I kind of step back a second and kind of just and if you watch the live portion of it, near the end you'll hear me go, reset Larry, reset. And I kind of had to reset everything and then kind of resolve it from scratch after like an hour in or something like that. And I was able to do it, but it took too much time that I didn't finish Q4, at least during the contest time, right? But yeah, but the idea here actually honestly is kind of straightforward. Once you are able to actually understand it and unlike me, not try to be too cute with optimization. And give me a second, let me try to pull up the drawing board. But the idea that I had was just, or the visualization that I had was just segments, right? I think one thing that before I start is look at the constraints, which I'm not showing on the board right now. Hang on, right? The constraints. L we don't really care about because it's just really N is the thing that matters, unless you do it some weird way. K matters obviously, but the other thing is that these things turns out to be matter: the time and the time supply. And after that, then you just have to declare state. And for this one, the important part is that, okay, the way that I visualize it is that, okay, so we have this timeline, right? And you have these goalposts, say, right? And then here, you have some time, so you have the position, right? And then you have some time for them. And then the idea is here is that for this problem is that if you get rid of this, then now this time gets added to the next time, right? So then the idea, I mean, I was trying to do this, but I was off by a little bit, and maybe there was a way to solve it, but I was just couldn't get it to be precisely right. But the idea is still skip, no skip, right? But yeah, but another way that you can think about it though is just think about it as segments, right? So let's say that we merge. You could say merging is a segment then, right? So let's say we have this segment, and if we don't merge, then we end the segment, right? So for example, here we don't merge, so we ended a segment there. But if we do merge, then now the segment goes all the way here. Or maybe, you choose in the future. So that's the way that I think about it. And then once you set that up, let's say you have a segment like this, right? Yeah, let's say you have this segment. And then what is the speed of the segment? Well, this speed of the segment is going to be the sum of the previous segment's speed, right? Because this is basically, because this speed is going to be the sum of this one and this one and all the ones that you skipped, right? So that's really the core idea of it. And it seems very brute forcey, and it is, to be frank. The states feels ridiculous, but well, you're only as good as your constraints. So, and here are my states, right? So current is the current speed. The speed of the last post or segment, or last sign, is it? Last sign or segment, right? And then left is the beginning of this segment. Right is the current end of this segment. And then K left is just how many merges do we need to do. And then it just becomes tick, no tick by ending the segment and keep going, right? So when we end the segment, what does that mean? If we end the segment, that means that we have to start a new one. But when we start a new one, that means that the previous segment, we should price it. We should calculate the cost. And the cost, this is just the length, right? So basically you have the right side here and the left side here. Then now this is your length. And then the current is just the current, it's not speed, but like it's the current cost per kilometer. So in my mind it was speed, but actually that's not precise. But yeah, because basically that's the cost. So then now that's the total cost, and we have the cost here, right? And then the new state. The new state is that, well, now the cost of the next segment, this is going to be the cost of the next segment, right? And here it is just the sum of the time from right all the way to left plus 1, right? So yeah, sum of time from left plus 1 to right, inclusive, right? So that's basically it. And this part we do it in one way by using prefix sum. Gonna skip this part in this explanation because prefix sum comes up a lot for whatever reason on Leetcode contest, so definitely you should be familiar with it. If not, then work on an easier problem before looking at this. You should be able to, the prerequisite for this problem is being able to do prefix sum like that, right? Anyway, and then now you have a new segment that goes from the new right to right plus 1, right? Just to kind of have like this one small segment. And of course, like a lot of these dynamic programming things, there are a lot of different ways to write it. It depends on your exact definition that you want to set up. Anyway, so yeah, this ends the segment, and this is the cost. And then if you keep going, it requires a skip, right? A skip or a merge, if you will. Sorry, if you merge, that means that you go at the current speed for the previous segment. So all we do is extend the previous segment by 1. And then you use one merge, and of course implicit in this is that when we increase this right plus 1 and left, in the future we will calculate the new cost. So that's basically the idea. I think I was trying to do that, but I couldn't figure it out for some reason. Maybe I was just off by 1. But yeah, you can also, and that's basically it, really. And then the first part is that you start with the initial speed. You go from 0 to 1 as the initial segment, and k is the thing you have left, and that's it. Yeah. So and the base case is just that, okay, when you're done, if you have merges left, then you return infinity because you have to use them all. Otherwise, then now you can finish the last segment, which is this is the distance, this is the cost required per km, per kilometer, and you multiply them, and that's it. I think this actually, now that I think about it, there are a couple of ways you can write this as well. For example, for this current speed, you can also just plus. Oh, let me do constraints real fast before upsolving, right? So then time is going to be equal to, current is, as we saw, 1 to 100, because it's the sum of the time, right, at the worst speed, so up to 100. Left is going to go up to 50, right goes up to 50, just like this is n, right? And technically, of course, it's not 50 times 50 because right has to be smaller than left, so it's like 50 times 50 over 2 kind of thing. And then k left is only, is it 30? Is it this? Oh no, 10 even, so it's even smaller. Whoops, right? And as a result, we do 2 recursions here, so it should be fast enough, right? 50 times 50 is 2,500 times 100 times 1,000 is like 2.5 million over 2 because left is less than right, so that's like 1 million. So we are pretty Gucci. But yeah, and that's basically it. The core part of it. The idea here is just kind of take. Honestly, I don't know why I took so long on this one. I think the idea and comes up a lot. I think there are some pieces that are a little bit tricky. Some of them is the time. It is very telegraphed that we should use the sum of time. I should have taken advantage of that more, and that's what you have here. And again, instead of having the cost here, you can just do, to keep going, you can just add this to current times position of like right plus 1 minus right or something. But I don't know, it's not that important, but you can factor that out. To have different states for sure. I think I just want to illustrate that. But that's it. That's all I have for this one. Let me know what you think. It's a tricky one, but to get it right implementation wise, I think the idea, the visualization is not too bad. Let me know what you think. I mean, I struggle with this one, so I don't know. But yeah, you could watch me solve it live during the contest. Next. Let's give it a YOLO submit. Okay, good. That was a little bit slow, but I don't know. How much time do I have left? That took like 6 minutes. Okay. All right. We have 2 hearts, do we? Okay. Well, straight row, integer n, integer k. There's just a lot of random integers. Position and time each of length n. Position list the position of signs in strictly increasing order. Okay, fine. Time represents the time to represent. Okay, fine. You must perform k merge operations. In one merge, get 2 adjacent signs and update the sign so that its time is okay. This is a very weird way to put it because updating the sign shouldn't update like the speed, but okay, fine. After exactly k merges. All right, what are the constraints? Constraints seems okay. L is 10 to the 5th, and that's the no. Position is the signs, right? So L is just the number of kilometers. Huh? Where does L come into play? L doesn't even come into play, right? Okay. It's just, well, maybe not direct anyway. Okay, so after exactly k merges. Okay, so here, position we have, after the merge. Okay, so if this, after the merge of 3 to 8, all the way 3 to 8. And then now the time is 11. Okay, is there, what is Q4? Okay, well. How am I doing on this anyway? I didn't really look at the time, I just look at Q2 time because I don't want to cheat too much mentally. Okay, N is 50 is interesting, K is 50. So what's N again? N is the number of signs, okay? K is the number of merges. Sum of time of I is 100. I don't know how that means or what that means. Times of I is equal to 100. What's times of I again? Oh, the length of time. Well, I mean, this one is maybe more important, but okay. Oh, so then you do state on it? Can you? Can ya? I mean, this is clearly set up to be dynamic programming, but so we have to figure out merge and not merge, right? So okay, so let's say we are at, so dynamic programming, we go, okay, so we are at index on the position, on the signs, k left, seems like we have to. Is that enough? No, because you could keep merging, right? So that's fine, right? So maybe the current merge? I don't know. I don't know if that's right, but it's only total time can only go up to 100, so that's why I want to maybe take advantage of it. And then now it becomes take no take 100 cube. Well, not even it is 50. This is 50 times 100. Maybe that's fast enough. I mean, that's fast enough, but maybe there's a way to do that enough. Okay, right. Okay, so if index is equal to n, what is the base case? So we're done. We are currently at maybe we haven't traveled yet, so this should be maybe the left index instead of the current merge. I mean, they represent the same thing, but the math is a little bit easier, right? Maybe, I don't know. Start index, and then now it just becomes okay, so the time, the speed, if you will, is equal to start index, or something like this. I mean, it's not quite right. All the way to the end, right? So like so in this case, it would be all the way to the end. So maybe like n. It's this. It's not this. It's p. What's it called? Prefix maybe. Okay. We have to do also k left is equal to 0, I guess. Return minimum time, so infinity. Right. Okay, prefix we'll just set up for t and no, that's fine. Time. Right. And so this is the speed. The starting location would be position of start of when. So okay, so then now it's just L. Let's just pick L. What's this small L thing? L minus the start times speed, right? So that would be the rest of the way. Okay, I think that's a good base case. Okay, then now it's take no tick, right? Take no tick, so we're at merge, no merge, let's just say no merge. Then here where best is equal to infinity, best should we just go index +1, we don't merge, so we do start. It's just start +1. Well, it'll be index +1 anyway, so we don't merge. So that means that we end our current position. So then, okay, fine. Right. And then k left doesn't change. I think this is technically no, it's fine. We do it no. That means that we're done to position index up to that sign. Right, okay, so we're done up to that sign, so then we now get the cost. So cost, right, so what's the cost? Cost is equal to, same thing really. So we go up to the index in time, we go from the start, just by definition, right? And then we times it by position of start. And that should be good for the no merge. I do want to point it out real quick just to see. But okay, fine. I just finish it. Okay, so merge. The cost is going to be free-ish. We just delay the cost. Index +1, we always do. Start, we just keep start. K left -1. And then that's it, right? Kind of. We have to do if k left is greater than 0. And that should be good actually. In structure. I don't know that this is right. We start at the 0. I don't. I have to make sure. I don't. this, I think the structure is right. I don't know that the setup is right. Okay, so I mean, and we are not correct yet. And in the, I feel like I'm missing the start. So start at 0. Oh, because we start at 0, not position 0. How do I change that? Oh, position. So there's always a sign at the first one. So okay, so we are always at 0. And so that's fine. Maybe that fixes that. So start is always going to be 0. We skip the first sign. Do we skip the first sign in this way? Okay, I'm just running through the code. Because basically, if you don't merge the, it's not merging the first one, right? You don't merge the first one. The first one doesn't. So this one doesn't make sense. I think it is. Maybe we're at 1 and we're trying to decide whether we want to merge it. Okay, that's really wrong in the wrong direction, but I think that's more similar. We just have to figure out maybe the cost is wrong more than that. Okay, so 1, so we start at 0. Okay, let's do something even base. Right, okay, it's 10. We have, what is that? 2. What is k? Can k be 0? K could be 0, so let's just do k 0 0. We have 0 10, and then maybe, I don't know, 1 1. I don't know. Alright, what's the answer there? 0? That's definitely not right? Because with no merge, what does a merge do exactly? Two adjacent ones update the sign. Oh, I has to be greater than 0 and also not the last one. Okay, that makes sense, because I was like, how do you do that? Okay, fine. Something is off for me. I'm definitely not being precise on this. I think the idea is right, but I'm not precise enough. Okay. Right, so okay, so if maybe this is if index is greater than 0, you don't merge on the, because there's no merging on the first thing, and we don't merge on the last one anyway, so that's just calculating the thing. So okay, maybe give it a spin. Okay, it just gives me infinity because we don't ever do this, I suppose. Well, this one should be like 10, right? So it goes 0 0. Okay, let's walk through it. That's what happens when you're not precise. Okay, because index means too many things for me. I think that's where I'm not precise about. Okay, so because this doesn't do this or this. Well, no, this doesn't make sense. This part I have to do index is greater than 0. So you always no merge on the first one. So then now this, yeah, we go to the first index, start at 0, k left, the cost, this would be 0 anyway, right? Yeah, this should be 0, right? So that's fine. Okay, and then the base case is wrong in here, right? So the speed is equal to the sum of that. Is that right? No, this is, well, no, that should be right. But this assumes that we merge. Is the no merge wrong? The no merge seems wrong. We want actually to go this distance, right? Also, this is wrong. I don't know what position start means. Maybe this is wrong too. Okay, yeah, no, this is definitely wrong. What am I doing here? That doesn't make any sense. We want to move position of index minus start, right? So that's the delta, that's the distance. Oh, sorry, how many? Yeah, and the speed is kind of wrong. It's like an inverse speed, so I'm lying on that one. But yeah, okay. So that's the length. This is the length. We don't merge, then we go to the next one. So here we should be doing this, and with time, prefix time. Maybe this. Maybe that's fine. Oh, index plus 1 as well. So index plus 1 could be L. Do we do it on the no merge or do we do it on the merge? I'm not consistent here either. On the no merge, you definitely need to clean up. So if you go to the next item after merge, okay, well. I think this is index plus 1 actually then. This is still out of bounds though. Wait, why is that out of bounds? Oh no, yeah, because index plus 1 should be, let's give an index. Okay, let's think precisely what this is, right? So this is time, this is the distance. But okay, so let's say you have 1. So this is 10, this is 0, no. Well, you don't want to, okay. Struggling a lot. Okay. The states are right. I think everything about this is right, except for I'm not handling the core part of the problem correctly. I think this is probably right, just because there's no way to be wrong, but the merge is not right. Okay, so what happens when we merge? When we merge, we basically skip the sign and then we accumulate, right? Maybe I could just do accumulate here instead. Yeah, maybe the prefix sum was too fancy. Okay, so we have accumulator of the time required per kilometer. No, but then you still need. I mean, yeah, that's why I did start, because you accumulate both on time and distance, right? Because you haven't traveled yet. Or can I do the math? No, you can't. So then you have to start. So you start at 0. Okay, so let's say you're at index 0. You want to say no merge with the next one. So then now you have to travel to it. Okay, I think the base case is wrong then, because then we cannot compare it to the next one. So this is the last one. So that's why I'm. Okay, I think this is where I was struggling a little bit. Okay, as a result, yeah, and I think the speed is off by. Oh no, maybe this is now fixed. Okay, let's see. Okay, so now we're very big. That's fine. Maybe I'm just off by 1. It looks big, but okay. I'm gonna just return 0 here real quick, just to see what the impact of this one thing would be. So this 10 is correct, actually. So that's what we want. So at least, I guess we're at the end, and we don't need to. Oh, at the end we have to finish the merge. No, I guess it just assumes that. Okay, so we're at the last one. If k left is 0, we go infinity. Otherwise, we don't have anything to compare to. So I think this is right, actually. Okay. Wait, is that true? No. This is only true if start is, I think this is this bit. 10, 92, 48, okay. I mean, this is only true if start is index, right? So, okay, if start is, so that means that, okay. Okay, I think this is true. But then now, if start, oh yeah, and this is just wrong. Should be, oh no, it's wrong. This is wrong, but because we have L minus S. The last one is always L, right? They say, okay, so we don't even need L. We don't care about L because it's just the last position. So then this is, yeah, I mean, I think this is right. Right? Why is this wrong? Okay. No, I guess it's the same. Maybe I just kind of had to, I just had to fix this part, I think. Okay, so maybe this part is right, even though I wrote it very awkwardly. Okay. 34. I have 38, which is good. It means that we're wrong in the correct direction, because that means that we have to remove something. How much time do I have? 1 hour. Okay, that's fine. Okay, it's time to tweak around this one. Okay, let's just make this 2 for now. Okay, so that's good. That's what I expected. Okay, and then now let's put in extra thing where we can merge at one, but we're forced to, okay, let's actually force to no merge first. Okay, same answer, which is what we expect. And then now let's say we have to force one merge. So either we go 19 seems wrong. No, I see. 19 is right because it merges here. No. If we do this merge, that'll be 10 and 2. So I am doing it wrong. My logic is wrong. Because if we merge these two signs... Oh wait, no, you can merge to the end. Okay. So you can merge to the last one. Wait, can you? What is n? I plus 1 is less than n. Can you merge with the last one? It's actually unclear. So you can choose I. So you can merge with the first one. And you cannot, but you can merge with the last one, right? Why wouldn't you always just merge with the last one? Because then you don't use it. Kind of confused now. Because can you just merge 8 and 10, get rid of the 8, and then now this is 9? Right? I guess you can merge the last one. I think this is a little bit off, or am I just confused? Maybe I'm confused though. Because n is not the index, right? Because it's 0 based, so I don't know. I think you just can merge the last one. Okay, we can merge to the last one, then maybe we have to do something like if index plus 1 is less than n. Okay, still 19 though, so, and the answer didn't really change. So maybe that's fine. And maybe this is okay. No, it still thinks you can merge with the last one though. So I don't know. This is very weird. Okay, but maybe that's just really wrong. I don't know. This is very weird. And I feel like I have to mix this minor adjustment to this problem, or solution rather. Okay, 19. Why is this 19 though? I guess you combine this one with this one. So then now... No, you can't combine the 0. So what are you combining with? The 1 and the 10. Right? And then now this is a 2. But maybe I misunderstood this. Times sub I. Like, we don't use the 6 here at all, so... I'm really confused why you don't combine the 8 and the 10. This is such a... Leetcode is so bad at this sometimes. Or maybe I'm just so bad at it. Okay, I mean, this is right. I don't get how is 19. One merge. You can you even do one merge? I guess you have to. K is n minus 2. Oh, also K is at most 10. So maybe I am wrong on this. Or like there's a more optimization here on K. Because for some reason I thought K is 100. Yeah, I think I'm just confused on this entire problem. Why is this 19 though? Oh, well, in my code it's 19, but it's 19 because we don't merge, we merge. We merge, but we gave it the 2 to this index. So we merged, but we added incorrectly. Okay. So how do I represent the merge? Okay. I'm understanding the merge incorrectly because you don't merge it forward. Because what a merge does is that it allows you to keep going at the speed that you were going, but accumulate it later, right? So what does that look like? So the state is wrong, I think. Okay. Because okay, I have to think about this. Jeez. How much time? 57 minutes. So basically we have skip, no skip still. We have the current speed. Okay, let's just do it really dumb for now. We have a current speed, right? And then we have accumulated speed. Maybe that's fine. So that now this is going to be 50 times 100 times 100 times 10. Maybe that's a little bit worse. I don't want to save this code, but I think it's fine. All right, let's just put it. And maybe there's an optimization here, but I don't know, right? Okay, so then now if index is equal to n, or n minus 1 like we said, then we're done. If k left is great, okay, so that's fine. Otherwise, then we are done because we're there, so we don't have to worry about it. And then now, and then now we use the new speed, and the new speed is going to be okay. Let's just use the old speed, and when we use the old speed, then now, so we're at okay, so yeah, we are at position of index, and now we're trying to figure out whether we want to use, so okay, so current position, okay, right, and now we want to go to the next position, right? So it's position index +1, and we want to choose, so this is the delta, right? This is the length of time, and we want to go, okay, we want to either use the old speed, and if we use the old speed, it's going to be go index +1, so the current speed accumulated, we have to add times of index, and then k left, because we merged it, so -1, so if k left, so right, so best is equal to f min, best go this plus the delta times current, right? Okay, so then now we want to use the new speed because we don't skip. So okay, so use the new speed. It's going to be accumulate. New speed is equal to accumulator plus time sub. Yeah. Okay. Time sub index maybe. I think we. Is it? Oh yeah, I think this is right. Maybe not. I don't know. Best is equal to f min. Okay. Best go index +1. This is the new speed. No more accumulating, k left, right? And then plus delta times new speed. Alright, maybe that's right, I don't know. And then now we go from the we do a question of first index, the current speed is going to be time sub 0, accumulator 0, k left is right? 0, 9, 47, 26. I mean, we're missing something, but that's fine, because this should obviously not be 0, right? So we go to the first one, we go, okay. Is it 0? Maybe this is 0. I don't know if that makes sense though. Use the old speed. 10, 10, 62, 34. I mean, okay. I mean, this is right. And I think this is right for that. So, alright, YOLO, let's go. Actually, I lied. Let me make a big case for a second. But I guess that was it. Okay. Let's see. What is the big case? L is equal to 10 to the 5th. I guess that's fine, right? Like, that shouldn't change anything. I don't think we do anything funky there. Actually, in fact, I mean, this lies anyway, because it's in the last thing, okay? We don't use prefix, do we? We don't use this anymore. But I do want to say, well... whatever, plus 10. Okay. And then K, we just set it to 10. And I think that's it, really. Well, position and time. Okay. Okay, so the running time complexity seems okay, maybe. But I actually, I forgot that I have to do this thing because Leetcode is cancer, but okay, so I don't know if this is right, but it should be fine, maybe. I don't know, we'll see. YOLO submit. Okay, well, At least it didn't time out. I spent so much time making sure that it didn't time out. But okay. So what does this mean? I put a better answer than it is expected, so that's actually pretty not great. How much time do I have left? 47 minutes. Okay. Okay. So we have 4. We're trying to do. So we merge. Oh, only one merge. What would be the merge? So we merge from 0. How do I write this? Okay. So 0 to 1. No way you would merge on. Well, you can merge. So go to 1 on 1. So okay. So the fastest speed on index is going to be 1. Okay. And then now 2. Did I forget like a k left is greater than, no, I do have a k left is greater than 0, so okay. Why would I do faster then? Okay, so let's say k is 0. What would the answer be? The answer is 6. That's actually weird. Okay, is that true? Maybe that's true actually, because it's just 1 plus 2 plus 3, so 6 makes sense. But then merging 1, okay. So you can only merge 1 and 2. Right? Is that true? Well, there are only 2 choices, merge 1 and 2, so then now you have 0, 3. Okay, I guess we can do this manually actually. Well, not manually, but with a test case. Okay, so that means that you have 0, 3. So if you merge these, then right? What does that give you? Is it 7 or 9? Huh, this gives you 11 even. So that's even worse. Okay, and then the other one would be if we merge to the 5. So then now this is 2, right? The merge, I think technically this has a number. So this is 9 and 7. So how do I get? Okay, so definitely wrong because. Okay, so both of these cases we have 11 and 9, but we put 7. Why do I have 7? Do I accumulate too much or something? Delta new speed, use the new speed. So what's the right one again? So 9 is the, so we want to merge it with the last cell. So we use the new speed twice. And then we use the old speed, right? Current is wrong. Use the old speed, No, this one should be right. What is current? Current speed, right? So new speed is the current speed, accumulating is 0. Should be right. Okay. We're close, but dumb on something. What am I doing? What am I dumb on? So, okay, so now we're at 2. We go, okay, do we use the new speed? If we use the new speed, I don't know. It should be no speed, and then is this off? No, this should be right. This is more like the previous speed, but okay, whatever. What, why? Is my min wrong? No, I mean, we're doing 7. Where do you get 7 from? How do you even get 7? Am I doing the 0th number wrong? 0, we go, okay, so we use the current speed, or we use the new speed, which is the same thing for 0. Okay, so I think after the first number doesn't matter, and then now from 1 to 2. Yeah, okay, fine, let's just print it out. This is too many states, but I hate it. Okay, fine. Okay, so this is 7, right? Because debugging sucks. Okay, so 2300, what does that mean? At the 012, the speed is 3 because you merge. Okay. What's this happening again? The speed 00. Okay, so you have to use the new speed, and that's fine. Okay, so this checks out, even though you wouldn't take that path necessarily. Okay, 11111 is 6. I think this gives rise to this, but which makes sense. But okay, so why is this 6? Because 1110. What does that mean? 1110. This is parsing index plus 1. Maybe my indexing is a little bit wrong. Okay, let's actually think about it. Let's do it this way. I think my indexing is a little bit, I mean, it's fine, but it's just not precise as I want. Use the old speed as current. Does this fix it? Let me just run it real quick. Nope. In fact, it got more things wrong. Well, I don't know. We didn't do it all the entire way. Okay, so now this is looking at the past, and then but this time and whether we should use it, right? So this is the delta. We go, okay, we should use the old speed, and then accumulate the current time index. Why is this wrong? Use the new speed. What is the new speed? Yeah, it's too confusing for me to change. Let's go back to here for now. I mean, I might have missed a part. Anyway, okay. So this is why this is wrong. But what's 11106? Let's just put it. Getting too confused. Okay. So index, the current speed at the current index is 1. Yep. Accumulating is 1. Okay. Is that true? Actually. We used the old speed, so we accumulated. No, this is not 1. This is okay. I mean, it's slightly better, but it's still wrong, clearly. And now the other stuff is wrong too. So, wait, is it? I mean, it is, but it is, but in the other way. So, why? Maybe this is here as well. Okay, that's just wrong. I have to think of, I'm not precise on this problem, and that's what's biting me. This is right again. Okay. Why is this 6? This is 6 because it gets from 1 to 5 in speed 1. What is this input again? No, it gets from 2 to 5 in speed 1 because it... Okay. I can't keep on scrolling up and down. It's just... I need a second monitor or something. But okay, let's just do it here. Okay. Okay, so we... 2, 3, the current speed. This, okay, so that returns 3. That sounds right. We're going from 2 to 3. No, wait, does it sound right? We're going from 2 to 5 at speed 3. Is this right? I'm spending too much time on this problem. I should have gotten it by now. Oh, actually, this is more right, right? Except that's one left, so it didn't do any merge. Okay, so if it does a merge, it does it 3. Where does it do the merge? 2. The current speed is 3. We have to use the new speed. And what is the new speed? New speed is 0 plus 1. But did we merge? We did merge. We merged the 1 to the 2. So then the 2 is the... Yeah. So where do you get this? So this is the input for 0, 1, 2. We're here. We're going, okay, we're going from 2 to 5. We could go either at 3 or 0 or at 1, but we can't. Now the current speed is 3, or we can use the new speed. So the old speed is 3, but is that old speed? No. Old speed, I think 3 is wrong. New speed should be 3. Or, well, yeah. New speed should be 3 because of... so this one is right. But how did we get here? Did I miss counting? We get here from here. Okay, so index 1. Current... let's just put this in. Okay, so this is index 1. Current speed is 1 from the previous. Okay, that's fair. The accumulating is 1. The accumulating is wrong. Well, index 1 we're comparing to these things. So, and the current speed is 1. Then the accumulation is going to be 2 because you skipped this. I think this is more right, but I think for some reason, well, where am I? Line 9? Okay. Maybe the decorator on the comment as well. Okay, so this is more right, but this is going to be the wrong answers on these two. That's for sure. So maybe it's not more right. Okay, so we're now back to here. Okay, so we're here, and this is by merging them. Merging the other two, we go okay, because we skipped this one. No, the current speed isn't 3. Am I messing this current speed wrong? Use the new speed. So we use the new speed. Is the new speed right? From here. Are we calling it right? So, okay, so that means that we're here. We want to travel one space and then we go, okay, well, we go to the 2, but the new speed is going to be, the current speed is going to be, no, that's the accumulator speed, not the current speed. So this should actually call, no, but then you went out of K left. Okay. Okay, so you have 0, 1, let's start over. 0, 1, 0 with 1 left, that's basic. Okay, that's fine. And then this course here, for using the old speed. So the old speed is going to be 1, so we skip this one. The accumulator is not 1. Despite, okay, so even though this gives, maybe it's giving me a little bit of luck, but this is not right, because the accumulator is not, so we're here. The accumulator is not 1. This is, yeah, okay. I think this is for definitively more correct, even though it gives us more wrong answer on the other ones. I think that's, okay. I think I'm pretty certain on this one, but there's more silly mistakes, so we'll keep going, but it can load into this. All right, so then now we're at index here. Where is it? Here we have speed 4, which is also just wrong. Right, I think maybe there's some like things here that's a little bit wrong. Okay, well, nope. Okay. Wait, is that what I'm putting? I'm spending all my time debugging this problem, and I wanted to go on Q4. Okay. I think this is more right though. Okay, because we're here, we go, okay, so the current speed is 1, yep. The accumulator is 2 because we skipped 2, but we're going from 1 to 2. We want to go, oh no, then here, we just rather, because we skip, we're going from 1 to 2. This is where my indexing is wrong, is a little bit messy. I think that's why, actually. Okay, I know that I kind of, but it is what it is. I think this is more precise. Yeah, but we have to kind of make sure. There are a lot of random. I have to keep track. I think these 2 indexes are wrong, but we have to look at it. Okay. Okay, so delta is your index minus index plus 1. So then now, oh yeah, and then this goes to 1. Okay. Maybe we're definitely wrong, but at least maybe we're in the right idea. Okay, now we're at yeah, okay. So then now we are either I think this is more right, but maybe it just takes me to, it's going to take me longer to recalibrate my head. Okay. Sad thing is I know how to do this one, but it's just, it is what it is. Okay, so 3, so we're here, and it returns 3, because it looks at 5, 2, the current speed is 3, which sounds right. Wait, what? But the wait. Current speed is 3. The new speed. Okay, so something is wrong here. I think this is actually this. Or maybe this is right. Wait. Okay, so this is what we had before we we indexed it. So maybe that would have been exactly the same, but okay. But now we have to figure out why this is off by 1. Okay, so this is now at 3. Current speed is 4 is definitely wrong. Because at no point it should be current speed 4. Use the old speed, okay, and so that's definitely wrong. Okay, so 2, 1, 2, means that's here. Current speed is 1. The accumulator is 2. Oh, that's why, because this is index -1 on the new speed. If we want to use the new speed, it is just going to be the previous accumulator. So we're here. Do we want to? We're going from 2 to we're here. The current speed is 1. The accumulator is 2. So we want to go forward in the new speed. This should be this, actually. But now this is weird again. I know that I'm just like off by something silly, but this is so annoying. Alright, so this is at the last element. The current speed is 3. That's fine. No, it's not. How is this correct for the other two, but not this one? That means my states are not set up correctly here somewhere. Either new speed or, I mean, there's only 3 things that I'm setting up, so. New speed, accumulator. I mean, this feels wrong. Current speed should not accumulator means here. But if the current speed is 3, 1, 3, so then now it goes backwards. Yeah, no, the current the delta is already 3, so that means that it is multiplying by 1. Why? It is multiplying by 1 because the current speed, well, current speed is 3, so that would be right. I mean, it's not optimal, but it's right. New speed is accumulator, which is 0 plus 1. So the new speed is wrong. Okay, that's fine. So the old speed is right. There's no new speed, is there? For the last one. Yeah, my indexing is bad. Okay, I think I have to go back to the other indexing. I think looking forward is the way to go and not looking backwards, maybe. Okay, well, I don't know if this is right anymore, so let's just run it. Okay. Okay. Okay, so now we're back at our original wrong answer. Okay. This is 3, is that right? So we're 0, 1, 2, we're here, we're looking forward, we go, okay. Our current speed is 3. We have to go at 3. No, we can use the new speed. What is the new speed? The new speed is the one that's wrong, so okay. New speed is accumulated plus 1, so it thinks it can do 1. Oh, so no. New speed is okay. Well, the current speed part is wrong. Something is wrong. Okay, so this is definitely wrong. I see. Now I see it because it tries to use the new speed, but you can't use the new speed. Because you're given all the accumulating, right? Accumulation. But then how did you get 3 as the current speed? So okay, so going from 1 to 2, I think my states are wrong with the new speed, with the accumulation. Okay. Okay, so going from 1 to 2, you skipped it, so then now you put the current speed at 3 at the next time. Okay, let's think. Okay, going from 1 to 2. Maybe my states, maybe I'm just thinking about it wrong. Going from 1 to 2, I only have 20 minutes left. I wasted all my time on this. Okay. Going from 1 to 2, we say, okay, well, we are not going, oh, I think doing the delta here is wrong. I think that's the difference. Wait, okay, so going from 0 to 1, we go, okay. Going from 0 to 1, we go, okay, either we take at 1 or we take at 2. If we skip 2, then the next one is, what happens when we skip? Skip, I think my accumulating is wrong. I definitely do, maybe I do need a start thing and keeping track of it. Yeah, maybe that is the less dumb way. Because, okay, so now we think of segments instead. I think that maybe, why is it so bad? Okay, how do I want to think? Reset. Okay. Okay, reset. Okay, so then now we go, okay, we have an index. We have a starting index, maybe? Okay. Just left, right, K left, right. K left is for sure. What would this look like? Right. Okay. So what would this look like? So if right is equal to n, then we are done. Then now we want to get, well, just even n minus 1, let's just say. So then now if k left is equal to 0, I guess, then we return, or if it's not equal to 0, then we just return infinity. Otherwise, then we want to get, distance is equal to, right, I mean, this is what I had the first time though, so I'm not like super confident about it either. That's why I'm pausing. Maybe I just suck these days. Okay, well, and then we just take no tick, right? Either we fingerprint a segment, fingerprint segments. Okay, so you have something like this. You go, okay, well, we start with 0, 0, and then we either expand the thing, and then now end the segment. Right, so take no tick. So then now we end the segment, then that is go left, oh sorry, right +1, right +1, because then now we start the new segment next, and then k left, yeah, we end the segment, then k left is the same. And then we have to add the cost of ending the segment. So ending is just equal to, why is this wrong again? Because I think this is wrong because because you don't add the right. Oh yeah, I know. Because this is wrong because when you did this, because when we merge these two, say if we merge these two, then now the segment, I mean, I think we can still do segment, but I just have to make sure I'm precise on this. Right, so then now when we merge these two, what does that mean? That means that this is the dominating number for thing, but so that means that the segment, let's just say if we merge these two to create a segment, the speed doesn't change. So this is not right. It's actually the sum of like, that's why I had current, right? Okay, fine. Maybe I had to do something like this. I don't know. And then it's the but then is this too much? 100 left right is going to be 50-50, and then k left is 10. Maybe that's fine. I don't know. That it's tighter for sure. But okay, fine. Right. So how do we kick it off? I don't even know. But yeah. Okay, fine. It's going to be this times current. But then now the current updates to be the sum of this stuff, right? I think so. Now this is the p time stuff, so it's like almost one delay kind of thing. Right +1 minus p time of left, so something like this. And then now keep going, it's gonna be k left, right? So okay, so something like this, go. The current shouldn't change, so it's just current, and then left, right +1, k left -1, and there's no cost because we don't pay it yet. Right, so something like this. Okay, so then left is going to be 0, right? And then we keep going by merging, but we can't. So is this? I don't know. Well, this will always be true, so maybe that's but This seems pretty wonky though. Okay, well, got 2 right answers. I guess I'm just not solving this today. Even though I think the idea, I don't know, I said that a few times too though, so maybe that's not true. Okay, so here, keep going the current time. So we merge. We want to end the segment. Then we update the current time. Is this the right? I think this the delta is right. The current should be right if we update the current correctly. Is this right though? We want to end the segment, so let's just say we have. I mean, this is clearly not right, but one of this should be 9, one of this should be 11. Okay, base case right, so that's good. But this being 2 is actually pretty bad, right? How though? Oh, because we end the segment on just 1 1. So maybe there's some like left right thing. No, it should be this. Someone like this, but I'm off by a little bit here. Well, maybe a lot, I guess. Because you can't end a segment, but then this is the current time. Okay, so keep going. Right. And the segment, is it here? This should be right. This should be right. This part is still the part that I'm not sure about, and this part maybe even. Maybe it's right here. Okay, I mean this is a little bit cleaner, or a little bit closer, and feels a little bit cooler, but and at least these 3 are consistent. But yeah, maybe this. Nope. And in this case, maybe I could have gone Q4, I don't know, but definitely not getting Q3. I feel like the ideas are like variation on this. It's just that I'm struggling today. 8 minutes, literally spend my entire time doing this. Like 4 lines of code or whatever. Why is this wrong though? 10, 10, 1, 72. So this is higher. Is this one? And this is too low. This feels right. I don't know. Am I just like? All right. Well, this I thought it would be, but okay, fine. Am I printing anything? I'm just gonna YOLO submit. Okay. Wow, I can't believe I solved it, honestly. But especially after all that, I was like, I didn't. Maybe I have to not include the 1. Okay. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, this explanation, everything in between. Stay good, stay healthy, to your mental health. I'll see y'all later and take care. Bye-bye.